Hey y'all, so today we're going to be doing Let's Defend, and what we'll be doing on Let's Defend will be Introduction to Network Fundamentals. So I'm just going to go through all these Let's Defends because I'm really starting to like them, and I'm thinking I'm going to pay for a VIP Plus membership coming up soon. So I'd like to go over this and I'll get your thoughts on it, but I already went over OSI Model the other day, so now I can go over networking fundamentals and revert back to one of my older videos that I also had. So today we'll go over the entire bit. I went through this first page, but I felt like it was enough that I can revert back and keep on going with all of you. So it says Introduction to Network Fundamentals. What is computer network? People and digital devices are entities that communicate with each other among themselves, just as people with a circle, devices in the digital world have a circle. It says this environment is created by these devices in a digital world called a computer network. In other words, the computer network in which at least two devices communicate with each other can be called a computer network. Purposes of computer networks. Computer networks have become usable for many different purposes. From the developing technologies, the main use of computer technologies are as followed: providing image and sound transfer, chat and online meetings such as this, hardware sharing, printer sharing, file data and information sharing, software sharing, central management, and support. So ARPANET and Internet. The Internet has gone through many development processes from the past to the present. When it first appeared, it was not as common as large as it is today. The mass that could have been used was very limited and mostly used for military purposes. The Advanced Research Project Agency Network, ARPANET, is a computer network considered the foundation of the Internet. The basis to Internet technologies are the technologies used in ARPANET. In 1969, ARPANET was connected to 3 university networks in the USA, creating a computer network. Later, the structures expanded and grew even more, and the image below shows the ARPANET in 1969 and 1982, and the computer network it is connected to. So, as we see, Utah, SRI, UCSB, and UCLA were the original 4, and then it grew out. That's the crazy thing that not many people know is like the internet was never meant to be for everyone. It was meant to just be for military, and then universities took it on afterwards, and then it really expanded because they thought that everyone would want to have it. So it said this network, which has been spread over a wider geographical area, has come to present day and created the internet. It is part of the training that the computer networks are, the purpose of use, and the history of the internet are discussed. Next parts of the training, types of networks, will be explained. So the question was, what is the name of the computer network that is accepted as the basis of the internet? And the answer is ARPANET. So we'll keep on continuing. It says type of networks. The computer network are geographically divided into many groups according to their size. There may be large networks with millions of devices in them, and small networks consisted of 2 to 3 devices. The following images show some types of computer networks by size. So first is your personal area network. That's just like personal area network that's around your person. So there's also a thing that's even smaller that's just on like your actual like watches or your phone. This is like the equivalent to like the laptop that I'm on, and just like smaller devices that are around me. Next, you have your local area network, which is 10 meters, 100 meters, or 1 kilometer. Room, building, like a whole apartment building, whatever that is, just the area and size of that. That would be a LAN, local area network. So then next is a MAN, as a metropolitan area network. That can be a whole city, the whole conjoining of all of the devices in a whole city. And then a WAN is wide area network, 100 kilometers to 1,000 kilometers, a country or a continent. So. Personal area network. Oh, it's actually going to get into the fine details of all of it. So, okay. Personal area networks refer to networks with minimal or small numbers of devices that cover very short distances, for example, up to 10 meters, for example, a mobile device and a wireless headset connected via Bluetooth. There are examples of this type of network, and there are only 2 devices in the small network, a mobile device and a wireless headset. Very small. Local area network is a little bit bigger. It goes local area network has a larger area than a PAN. The number of devices in it is much more, and it is much more commonly used and found networking type. Sometimes a network with 2 devices can also be called a LAN. The fact that it supports The fact that it supports much more than 2 devices in the term of capacity and geographically spread over a wider area indicates that the LAN type network, for example, Home networks and shared networks within the building can be given to the example of a LAN. So next we have a MAN, which is many conjoining LANs all together. So metropolitan area network. These metropolitan area network is a geographically city-sized computer network in which many LAN computer networks are interconnected. It connects networks with fiber optic cabling. Then we have a WAN. Wide area network is a company or a computer network that is the largest geographical among computer networks. This computer network is so large that it can even contain continents. It hosts all the computer networks within it. An example of this computer network is the internet. The following address can be seen in intercontinental fiber optic infrastructure around the world. Submarine cable map. Submarinecable.com. I have never seen this. Oh, I have seen this. Yes, this is interesting. Very interesting. Wow, that's cool. Huh. Cool. And then we have campus area network is, let me zoom out, is a geographically smaller than a MAN and larger than a LAN. The computer network can contain several LANs. Usually the computer network of university institutions and private companies are given this example of this computer network. In this part of the training, there are types of computer networks according to their size are discussed. In the next part of the training, the topic network topologies will be explained. So the question is, sort them according to their geographical size from the largest to the smallest. Alright, so largest, WAN, next would be MAN, next would be LAN, and then PAN. So, there we go. Didn't it only... Oh, it wants gotcha. There we go. Didn't even want any capitals. Alright. So, the next is network topologies. It is a visual map to understand the physical or logical structure of a computer network. The location of devices and cables in the network are among the factors that determine the network topology. There are many benefits to having a network topology. For example, it is possible to see which of these devices in the network will be affected if the devices on the network fails to perform its task. If you are looking for network topology of a large network, it is possible to see the subnets in the network and the devices it is connected to. Network topology is divided into two types, physical and logical. There is a big thing that you have to understand with physical and logical. Most people can really wrap their head around physical. Logical takes a little bit more time to understand. So as I go through this, if you're newer to IT and information technology, it might take a little bit more time to understand logical, but everything within all of this comes with time, so it won't be an issue. So physical. It is a type of topology in which all devices and components in a network are drawn in terms of their exact location. So you might have a server in one area and a computer in another, and you're going to see that. Server might have a bunch of logical, but you're going to see just physical and physical. That's the great part about physical. You can see everything. It says, looking at this topology is seeing which cabling is made over which paths and devices. What is seen in the drawing has a physical counterpart. For example, if there's a network device in the path from A to B, the device is seen in the physical topology. Very easy to understand. Logical is where it gets a little bit more confusing. So logical topology, it does not show the exact location of the device in the topology like physical topology. It often contains fewer elements than the physical topology because data flows and is important in the logical topology. For example, data going from A to B may not be included in the topology it passes over C between A and B, and C has no effect on the data that would need to display on it. In this topology, it is the path of the data flows that is desired to be emphasized rather than the physical placement of the devices. Some topologies are described in the following: ring topology, and then I'm gonna, star and bus, and mesh, and partial mesh, and bus, and tree. So, got each one of these. So, they're really easy to understand. Ring connects all the devices in a ring. There's not much more to it. It says advantages: it performs better than a bus topology in the heavy data traffic. It does not need Central node is easy to install and configure and only has 2 connections. Change to add a new node. Due to its point-to-point structure, error checking or repair can easily be done. Disadvantages: when there's a node that does not transmit, the entire network is adversely affected. That's where if one of these are cut, the whole thing's dead. The whole network can be adversely affected if a node is added or migrated. The transmission delay in the network increases in direct proportion to the number of nodes. If you have 50 nodes, it's going to take a while to get all the way around. And then bandwidth is shared across all the connections between the devices. So, star. Each node in the star topology is connected to a central node. All data flows through the central node. Star topology is one of the most common computer networking topologies. You have switches, you have routers, you have firewalls that everything connects to. The advantage is when the node is disconnected, other nodes are not adversely affected. That's what happens with each one of the end workstations or the endpoints. In the case of adding or removing a new node, the operation of the network is not interrupted. It provides good network performance under heavy traffic and is suitable for use in large networks with multiple devices. The disadvantages: the cost is high due to cabling requirements for each node to be connected to the central node, and in case of a failure of the central node, all connecting nodes will be affected, so the connections are broken. So if that switch, firewall, that's why it's good to have load balancing and have multiple ways of it connecting. But that's... Next, we have mesh topology. It is a network topology in which there are no central nodes, and each node can be directly connected to each other. So this one can be very burdensome because all of them have to be connected. They can all translate and talk with each other. It's just, as you see the information, how it's sent out, there's no central one that's proctoring all the information properly. So it says full mesh. In a full mesh topology, each node in the network is connected to all the other nodes by cabling separately. In this topology, it's unlikely that the connection between two nodes will be broken because there are alternate ways to connect. So yes, there's many ways to connect. This is more of a peer-to-peer network, but you're not going to see something like a switch, firewall, router, anything in that regard for most peer-to-peer. Some sources you can have peer-to-peer, but it's not as common to have that. So then there's partial mesh. In the partial mesh topology, although each node is not directly connected to all the others, they are largely interconnected just like a full mesh. There are alternate ways to reach the target nodes in the case is disconnected. So then you have bus topology. Bus is a topology where nodes are connected on a common path and data is transmitted, made with a bidirectional connection on this path. In the bus topology, each node receives every transmitted data, even if it does not belong to it. Since there is no hierarchical order among the nodes, there is no transmission priority. So, one advantage, adding nodes is pretty easy. Another one is good for small networks. Extended the bus is easy, and the use of a single cable reduces the cost. Disadvantages, there's a lot. There's a high probability of packet loss in the network because of if they're all trying to transmit at the same time, it's going to be hard for it all to work. Performance may suffer as bandwidth is shared amongst all the nodes. Exactly my point. The rate of being affected by the errors in the network is high, and if there's a break in the main cable that provides the transmission, the network is divided into two and problems arise in the packet transmission. Next one is point-to-point topology. Point-to-point topology is the simplest topology and consists of two nodes connected together. For example, a passing call between two phones create a point-to-point topology, or direction connected between two computers creates a point-to-point topology. Tree topology. Tree is a hybrid network topology formed by connecting star and bus. Tree topology has hierarchical order, and each node can have a number of subnodes. As you see, there's 3 switches on top. Each switch connects to 2 different computers. In this part of the training, where the network topology is, this type of some network topologies are discussed. In the next part of this training, the subject of the OSI reference model will be explained. So, it shows 6 different pictures. There's a bus, star, ring, partial mesh, tree, and point-to-point. So it says, what is the name of topology number 1 in the picture above? That's a bus. So just one bus topology. And then what is the answer for 2 and above? 2 is a star. And then 3 is a ring. 4 is partial mesh. Doesn't look like partial mesh because it's 4. I don't think that. Oh, I guess you could just say mesh topology. Oh. And then what's number 5? Tree. And then 6 is the point-to-point topology. Oh, it said underscore, but I guess it wants text. Next. Alright, so just talked about this in a recent video. You can check that out. OSI reference model. This part of the training is briefly discussed. The details of OSI reference model are in the second part of the training series. What is the OSI model? The OSI is the Open Systems Interconnection Reference Model. Was developed by OSI Organization of Standard in 1978. The OSI model is a model created to enable communication between different operating systems. With the model, it has become easier to understand network structures as reference quality and a layered architecture. Each layer in the OSI model has separate tasks. There's a hierarchical order between these layers, and each layer serves the next layer. The number of layers in this OSI model is 7. Actually, it's 8. I'll talk about that in my other video. You're the 8th, and I want to make sure that that is. So I'll actually breeze through a lot of this because you can check this all out in my other video. So I'll just give you the brief overview. Physical, data link, network, transport, session, presentation, and application. So what is the first layer responsible for error checking in the OSI reference model? Error checking, error checking is probably is it data link? Yes. And then answer the format. Oh, so it wants it in the order. Please enter the answer in order from left to right without leaving any spaces between the numbers. According to the numbers below, correctly organize the OSML starting from the physical to the last layer. So last would be 3. So it's please do not throw sausage, pizza away. And then, so there's many different mnemonics. I talk about that in the other video as well. And so in which layer the OSI reference has FTP, HTTP, and SMTP protocols. So that's the application layer. All right. So network devices. In the computer devices, there are network devices each responsible for separate tasks. Without these components in the computer network, the network cannot fully fulfill the task. Therefore, knowing the tasks and capabilities of network devices allow for solving problems in the network and understanding security breaches in ways that solve problems is reached by taking quick action. In this part of the training, information about the network devices in the IT network will be discussed. So there's switches, routers, hubs, repeaters, bridges, modems, firewalls, gateways. So I'll give you a brief overview because I've already talked about this in one of my other videos, and I'm going to link that. That's one of my networking videos that I did prior to. So switches connect devices on a local area network, so connects them all internally. Routers will allow you to get to other people's local area networks or the WAN, so it sends information off to the internet. A hub is like a switch, but it's very dumb, and it just sends information all, as you see right here. It just operates on layer 1, and it'll send information to every single port that it comes in on. Repeater keeps the information going. So it says the repeater is one of the network equipment working at layer 1. It's the exact same as a hub. It's not. They're both on layer 1. That's what I mean by the exact same. And there are only 2 ports in the repeater device. These ports are transformed from incoming signals into outgoing signals, transmitted to the destination. It strengthens the weak signals on it and enables to transmit data to longer distances. It is referenced similar to a hub, but does not have as many ports as a hub. A bridge. A bridge is one of the network hardware running on layer 2. So there's the 2 that are running on layer 1, which is a repeater and a hub. And there's 2 that are running on layer 2, which is a bridge and a switch. So a bridge is one of the network devices running on layer 2, according to the OSI reference model. The bridge performs packet routing by connecting 2 computer networks. Although it has a similar task as a router, it is a very similar device with fewer ports than a router. It also has separated from the router by working at the second layer. The bridge can be used LAN-to-LAN connections. A modem are generally small-sized network equipment in which features of device such as switches are gathered together. It contains a small operating system and is generally used for home network access to the internet environment. It may have 1 or more ports on it. In addition to possibly providing internet connection, it is used wireless device gathered from modem to wireless supported modems. So the thing with a modem, it brings in the information that cannot be understood through the coaxial cable, and then it allows it to be digital. So it brings it in as analog, and then it converts it to digital on your own environment, because how the devices need to be understood is when they're going from long distances, they have to be going through coaxial, and they can reach that distance because they're either going to be going through some other type of medium. But when they get into your local network, the data is going to be transferred through Ethernet. So firewall, it's pretty similar to a router. The firewall is one of the network devices running on layer 4, according to the OSI. Network is vital to network hardware located between the internet, which is considered insecure network, and the existing task of firewall, which is one of the basic requirements necessary to ensure security of the network. It is to block and allow traffic according to certain rules. Although there are many types, the most commonly used is a type of firewall hardware and network device. Having a firewall device alone does not protect you against external threats, because attackers can even infiltrate networks with the firewall. These firewalls must be configured correctly. Incomplete or incorrect firewall configurations can negatively affect network performance as well as cause security vulnerabilities. So you have to watch when you open ports, what ports you're opening up, what you close down, what you want your users on the inside to be able to access, and where they're going to be going. Gateway. Gateway is one of the networking equipments that can work on every layer of according to the OSI model. The gateway is a network component that provides interconnection communication located between 2 networks. In other words, a connection network. It connects networks. Although it is similar to the router devices in terms of function, it differs from a router that its ability to work in every layer. In addition, there are not only hardware but also software gateway types. Gateways are a gateway for other nodes in the network, although this device can go out of the network and communicate with nodes in other networks. So the question is, the X device in layer 2 only delivers the incoming packets to the destination connected to its related port, but Y device in layer 1 sends the packet to the device connected to all ports. What is the name in X and Y respectively? So the first one, layer 2, is a repeater, the second one's a hub. No. The X device in layer 2 only delivers the incoming packets to a destination connected to its related port. Would it be switch? I want to say switch. Switch and hub. Yep. Alright. So we got TCP/IP model, which is the newer version of the OSI. And then we have IP address mechanism and then network address translation. So I just talked about this TCP/IP model along with the OSI in recent video that I just shared earlier. So you can go to the OSI model. You probably already have listened to it if you would have went and watched it already. So it says, what is the TCP/IP model? The TCP/IP model is designed and developed by the Department of Defense in the 1960s. When the TCP/IP model was introduced, there was no model that set the standard to computer network communication yet. In the model, it was determined how the network communicates and should be a basis of it. So the TCP/IP model has layered architecture and consists of 4 layers. So it slims down the 7 that the OSI has. So you got network access layer, internet layer, transport layer, and application. So the highest 3, application, presentation, and session, are all inside of here, and then the bottom 2 are inside of here. So I think that they might, yep, they talk about right here. So physical data link are in the network interface, and the top 3 are all up here. And so it just goes transport, transport, network to network, and that's how it all goes. So very similar. I talked about this in the other video too. So go through all this. It says correct the order. I have not memorized this one as well as the other one. So I guess you could do AT, N, AT, it's almost like anti? I don't know, if anybody has some good mnemonics, drop it down in the comments below. I'd really enjoy that. I haven't learned that, because please do not throw sausage pizza away is what I have for the OSI. But TCP IP, I guess it would be INTA, INTA. So I'll eventually learn that one. So it'd be 2, 3, 4, 1. Alright, so we have IP address mechanism. So what is IP address? IP address is the ID of device's network address. Connecting operating systems are performed using IP addresses. IP addresses are divided into IPv6 and IPv4. Examples of both are below. So got 192.168.4.1, and then you have a lot of numbers altogether for IPv6. So you got the difference between IPv4 consists of 32 bits, and then the difference with IPv6 consists of, what is it? 128 bit. So that's the difference, is 32 to 128. So IPv4 was made in 1981, and IPv6 was made in 1999. Still haven't adopted it, even though the amount of addresses is way greater. So there's private IP addresses, which is not needed for IPv6, but for IPv4 you have the 10, the 172.16, and the 192.168. So got those 3 ranges that you're able to do, and then you got your local host, which is the 127.0.0.1 all the way up to the preceding 127.255.255.255. So you have the whole range, and then we also have class A, B, and C. So these are the different host and network ranges. So if you use something as like a class A, so let's say you have the 10, so you have 10 for the network, and 4 skip, so then 32. After that, this is 0, which is 16. So then we have 8, 4. So that's everything for the first one. So the first one is 168, 172. So go 172. Then we got 128 skip, 64 skip, 32. We got 16. So then we got that. So then we got 128, 64, 32, 16, 8, 4, 12. And then the last one's 1. Ooh. 128, 64, 32, 16. 128, 64, 32, 16, 8, 12, and then the last one's 1. What am I missing? Which of the following IP addresses are in the same network according to So we're looking for the 192.168 something, and that'd be the exact same. So we're looking for there we go. So there's the 192.168.4.3, and then we have 192.168.4.7. What is happy addresses that are in the same network according to the information given below? So within that subnet range, I think it just wants the smallest in general. So how we do this? So we do that, then that one, and then 168 dot. Probably do the 10, and then we look for 3, which should be 1. But we actually want we want that beforehand. Got 1. Put 1, 2, 4, 5. Before 4, we need 7. 8's probably gonna 8 will be last. And 9 go right here. So it says that it wants it all to be in the class C, which with class C is just the last octet would all be the same. And that's what I was looking at earlier. So we just want which of the following is the same network according to the following information given below. So answer format, smallest to largest. There's nothing else in the same range as the 10. There's nothing else in the same range as the 1. The 2 and the 7 are in the same range. 4's not in the same range. 9's not in the same range. Neither is the 8. I could have sworn that's what I had before. 2 and 7? I might typed in different. I meant 2 and 7 earlier, so I'm very confused by that. Alright, so going back to this one, we got 128, 32, which is 160, and then 32, 0, which should be 16 would be nothing. Then you 8, 172 dot 128, 32, or 64, 32, 16. And then you got 128, 64, 32, 16, 8 and 4, which is 12. And then the last one is 128, 64, 32, 16, 8, 4, 2, 1. I already sent that answer. Yes, you're right. Oh, yeah, that'll do the trick. That'll do the trick. I didn't include the B after the fact. Both right on both the answers, just little mistype. So 172.16 dot, what was it? So we got 172.16.12.1, and then it's in the B class. And then we have the 2 and the 7, which is the 192.168.4.3. And then in that same class of the subnet of 255.255.255.0 is also 192.168.4.7, since they both have the last two numbers inside the range of the original 3 in the front. So, all right. So now we're on a network address translation, which I only really understood about a year ago. So, network address translation is a method of converting private addresses to public IP addresses. Since private IP addresses are not routing IP addresses, these IPs cannot be used on the internet. These IPs allow communication in the local network only. Thanks to NAT, limited IPv4 networks are used more sparingly in addition to the kind of network segmentation provided thanks to NAT. It is beneficial in controlling and securing connections coming from outside the networks into networks in order to use the NAT method. A device with gateway must perform packets routing. These devices has a NAT table, and IP address conversion are performed by looking at these tables. Although NAT is often used as a solution to running out of IPv4 addresses, it also has some disadvantages. Some of the advantages and disadvantages can be seen in the table below. Some of the advantages are it slows down the exhaustion of IPv4 addresses, IP address conflict is significantly reduced, and connection setup flexibility increased. Disadvantages: end-to-end traceability is reduced since you lose it after the NAT translation. Some applications do not have NAT compatibility, and it causes a delay with that conversion time. So, example of a NAT. NAT is quite simple in nature. The simple working logic shows in the picture below. So, as you see, it'll say what its destination is and where it's going to. So it says inside the local IPv4, it'll say its address, and then it's inside the global IPv4 address, it'll say that. So it'll translate it as it goes. That's what it says it is, because it'll always say whatever the router is, and that's where the router will figure out where that information is going. So within the device IP address of 10.6.1.2 goes to the internet, it must first transmit the packet to a gateway device that provides the internet output. The gateway device receives the packet, determines the network in which it will forward the packet to and destination address by looking at the information fields in the packet. After seeing that it has an IP address belonging to the internet, it connects the changes to the packet by using the information in the NAT table. In other words, it performs NAT conversion. After conversion, it forwards the packets to the network device, forward packet into destination IP. When the incoming response packet arrives, it redirects the packet to a relevant device in the internal network by performing the reversal of similar operations, and the packet transmission are performed together with NAT transformation. In this part of the training, what NAT is, and its advantages and disadvantages, and the simplest working logic of NAT is discussed. So, boom. That was everything. Just like that. So, if you have any questions on networking, I got 2 other videos, OSI Model video and the networking video. Both will be able to help you out. So, if you have any questions, leave them down below. Hope you like this video, and if you subscribe, I'd greatly appreciate it. Let me know any other videos in the future you want to see. I'm going to do a bunch more Let's Defend. I also have the whole PowerShell series that I'm working on, so I'll be working on that as well. So, hope you liked it. Have a good day. Peace.